A multi-wire branch circuit has specific requirements in electrical codes to ensure safety. Even if individual receptacles are not sharing a common yoke or device, if they are part of a multi-wire branch circuit, a two-pole breaker is generally required to disconnect power to them. The primary reason for this requirement is to prevent a potential shock hazard. In a multi-wire branch circuit, multiple ungrounded conductors, commonly hot wires, share a common neutral conductor. If one of the ungrounded conductors is accidentally disconnected while the other remains energized, a difference in potential can exist between the disconnected conductor and the neutral. This can create a shock hazard if someone comes into contact with the disconnected conductor. The National Electrical Code, or NEC, mandates that all ungrounded conductors of a multi-wire branch circuit be disconnected simultaneously. This requirement is satisfied by using a two-pole breaker. A two-pole breaker is designed to trip both ungrounded conductors at the same time, effectively removing power from the entire multi-wire branch circuit. This simultaneous disconnection minimizes the risk of a shock hazard. Here is a deeper dive into multi-wire branch circuits and why the two-pole breaker requirement is important. Multi-wire branch circuits are used to provide multiple circuits with a single neutral conductor. A common example is a 120 volts or 240 volts multi-wire branch circuit in a residential setting. This circuit typically consists of two 120 volts ungrounded conductors and one neutral conductor. The two ungrounded conductors are connected to opposite poles of a 240 volt source, such as a two-pole breaker in the electrical panel. Each ungrounded conductor serves a separate 120 volts load, but they both share the same neutral conductor. The advantage of using a multi-wire branch circuit is that it reduces the amount of wiring needed, as only one neutral conductor is required for two circuits. However, this configuration also introduces the potential for a shock hazard if one of the ungrounded conductors is disconnected while the other remains energized. In a standard 120 volt circuit, if the ungrounded conductor is disconnected, there is no voltage present and no shock hazard exists. But in a multi-wire branch circuit, if one ungrounded conductor is disconnected, the other ungrounded conductor is still energized and connected to a load. This creates a voltage difference between the disconnected conductor and the neutral, posing a shock risk. Consider a scenario where an electrician is working on one of the receptacles in a multi-wire branch circuit. If the electrician only disconnects the ungrounded conductor serving that receptacle, the other ungrounded conductor in the circuit may still be energized. If the electrician accidentally touches the disconnected conductor while also in contact with a grounded surface, such as a metal enclosure, they could receive an electrical shock. To prevent this, the NEC requires that all ungrounded conductors of a multi-wire branch circuit be disconnected simultaneously using a two-pole breaker. When the two-pole breaker is tripped, both ungrounded conductors are disconnected, eliminating the voltage difference and preventing the shock hazard. The two-pole breaker provides a simple and reliable way to ensure that the entire multi-wire branch circuit is de-energized before any work is performed. It is important to note that the two-pole breaker requirement applies even if the receptacles or other devices in the multi-wire branch circuit are not physically connected or sharing a common yoke. The key factor is that they are part of the same multi-wire branch circuit and share a common neutral. Even if the receptacles are located in different rooms or on different walls, they must still be protected by a two-pole breaker. There are some exceptions to the two-pole breaker requirement. For example, if each ungrounded conductor of the multi-wire branch circuit is protected by an individual single-pole breaker with a handle tie, the simultaneous disconnection requirement may be satisfied. A handle tie is a device that mechanically connects the handles of two single-pole breakers so that when one breaker is tripped, the other breaker also trips. However, handle ties are not always reliable, and they may not provide the same level of protection as a two-pole breaker. Therefore, the use of a two-pole breaker is generally recommended for multi-wire branch circuits. When installing or working on multi-wire branch circuits, it is essential to follow all applicable electrical codes and safety regulations. This includes using a two-pole breaker to disconnect all ungrounded conductors simultaneously, as well as properly identifying and labeling the circuit. It is also important to use appropriate personal protective equipment, such as insulated gloves and tools, to minimize the risk of electrical shock. Here are some additional points to consider regarding multiwire branch circuits and two-pole breakers. Firstly, the NEC defines a multiwire branch circuit as a branch circuit that consists of two or more ungrounded conductors that have a voltage between them, and a grounded conductor that has equal voltage between it and each ungrounded conductor of the circuit, and that is connected to the neutral or grounded conductor of the system. Secondly, multiwire branch circuits are commonly used in residential, commercial, and industrial buildings to supply power to lighting, receptacles, and other equipment. Thirdly, the NEC requires the multiwire branch circuits be installed in accordance with specific requirements, including the use of a two-pole breaker to disconnect all ungrounded conductors simultaneously. Fourthly, the two-pole breaker must be readily accessible and clearly labeled to indicate that it controls a multiwire branch circuit. Fifthly, the neutral conductor of a multiwire branch circuit must be sized to carry the maximum unbalanced load, which is the difference between the current flowing in the ungrounded conductors. Sixthly, it is important to avoid overloading multiwire branch circuits, as this can cause the neutral conductor to overheat and potentially lead to a fire. Seventhly, when troubleshooting multiwire branch circuits, it is essential to use a multimeter to measure the voltage between each ungrounded conductor and the neutral conductor, as well as the voltage between the ungrounded conductors themselves. Eighthly, if the voltage readings are not as expected, there may be a problem with the wiring, the breaker, or the load. Ninthly, it is important to consult with a qualified electrician if you are not comfortable working on multiwire branch circuits or if you suspect a problem with the circuit. Tenthly, always prioritize safety when working with electricity. Turn off the power to the circuit before performing any work and use appropriate personal protective equipment. Understanding the NEC requirements for multiwire branch circuits and two-pole breakers is crucial for ensuring electrical safety. By following these requirements, you can minimize the risk of shock hazards and protect yourself and others from electrical injuries.